Hi, if you remember, I installed a patio heater a while back and now I'm back at my fuse panel and I have to open it up again. Maybe I just should keep it open. See, there are a few benefits to make a video around your DIY project. One is that if I have any knowledge, I'll share it with you and we can have a conversation around it. Second is the juicy YouTube money. And third is that you guys get to review my work and tell me what I did wrong. And fourth, I can make a follow-up video about it and make even more juicy YouTube money. And of course, the most important part is sharing knowledge and the sense of community. No, but really, thanks to you guys for pointing out my shortcomings. I think it's important to make this video and show you what updates I have to make on my system and make it better. So, let's open it up again. First things first, turn off the breaker. Now, first things first, some of you told me that I talk about saving the planet and being efficient and then I put a patio heater that heats outside. Well, that's true, but we installed it due to necessity. We thought we are living during a pandemic and if we had to meet somebody, we'd rather meet them outside in the patio. And having a heater there would help our guests not freeze. And it is an efficient electric heater without any gas emissions. Does heating outside contribute to global warming? I don't think so. And also maybe in the future I install some solar panels and then I'm sure that it's clean. Second, you guys say my heater doesn't use more than 17 amps. So why use a 30 amp breaker here? I should change it to 20 amps. That is a good idea in general. If you know you're not going to consume more than some amount of current, then why not put a proper breaker for that current only? The reason I designed for 30 amps in general was that I was worried I may have to change my heater later to something higher power to create more heat, but I don't think I'll change it, it's good enough. But in general, I think it's okay to leave it at 30 amps since all my wiring is 30 amps. Some of you say, hey, the wires inside the heater are not designed for 30 amps and they may melt and burn. What does that even mean? It's not like the 30 amp breaker will force more current into the heater. The only reason there would be more current going into the heater is that there is already a failure inside the heater. And in that case, well, there's more problems than just melting wires. It's like saying your lamp is 100 watts and only draws 1 amp. So why put it on a 15 amp breaker? We should change the breaker to 1 amp. So if there is a short inside the heater that draws exactly 30 amps of current and the breaker doesn't pop, it means that there is a lot of extra heat generated in the box of the heater, which will eventually fuse the short open or will even make it more short and the breaker will pop. It is in general manufacturer's responsibility to make sure all the sparks and fires are contained within their product and doesn't cause a house fire. But I guess we can't really trust manufacturers with everything, can we? So in any case, because I'm not gonna draw any more current than 20 amps, I'm gonna put 20 amp breaker. In North America, when we put breakers on 240 volts, we use 2 ganged breakers like this that disconnects both live wires at the same time. But unfortunately for me, apparently due to pandemic, the ganged version is not immediately available. So I bought 2 separate 20 amp breakers. It performs exactly the same, just that if there is a short, only one of the breakers will pop and the other one will stay connected. So if you want to work on the problem, one of the live wires is connected and that could be dangerous. But if you look here, there is a hole in the breakers that you can pass some rod through them and connect them both together so that if one pops, the other one pops too. Wrong! In good old days, you could have shoved the nail in the hole between the 2 levers so they would turn on and off together. If the breaker popped, the lever would move all the way back and you had to manually push it on again. You could have even held on to the lever to keep it on and let the high current pass through. Some people even put wires in there to keep it on and set things on fire. That's why we can't have good things. Nowadays, breakers don't allow that. See, if I push the lever like this and manually pop the breaker, see, this is already disconnected and moves half the way back and I can't turn it on like this anymore. I have to reset it by pushing it all the way back and forth again. And because it moves back halfway, ganging it with a nail doesn't help either. In double breakers, there is a mechanical link between the 2 breakers you see here. I've removed the link between the 2 levers and a sticker here so we can see the mechanism in there. If I try to turn it, see, both breakers pop and I can't reset one side either. I have to reset both sides together and then turn it on. Safety. So I can't use my single 20 amp breakers and have to use my dual 30 amp breaker. I checked the code, it's fine to use 30 amp or less breaker on 10 gauge wire independent to the load. But before I put the breaker back on, there's another issue you guys brought up. See, when I opened the hole here beside the fuse panel, I drilled into the wooden stud here. And you see that around this wire, the stud and the plastic are exposed. And you guys told me that if there are any sparks for any reason in the fuse panel, it could jump to that piece of wood and set things on fire. Although I don't think that was a real concern here, because you can see the wood here is exposed too. In any case, wherever they pass the wires through the fuse panel holes, they put this plastic thing inside the hole, which in my opinion is not to prevent the sparks to jump to the wood, it's to prevent the sharp edges of the box to cut the wire jackets. Just to be a good boy, I bought this plastic thing anyway, and I'm gonna see if I can shove it around the wire. But before that, there is something even more important, which is called anti-short bushings. See, you guys kept commenting about this, but didn't say what it does or where it goes, so I was confused as hell. Until I did some research and realized that those anti-shorts are to protect the wire against itself. See, if this steel jacket is squished at the edges where it's cut, it can cut through the jackets of all the inside wires and short them together. And this is where typically the steel jacket is squished. See this wire holder, you tighten the screw and it squishes the wire jacket so that the wire doesn't move. And the sharp edges of the jacket here can cut through the jackets of the inner wires and short them. So this anti-short thingy goes around the wires and inside the steel jacket like this, to make sure the sharp edges of the jacket won't cut the wires. And this was the most important thing in my opinion. Everything else was not that immediate, but this could cause immediate danger. Although if the jacket had shorted my wires, the breaker would pop after 20 seconds of 60 amps. So I have to put those anti-shorts on each end of the jackets. One here and one inside here, one from here to the switch there, and one from the switch to the heater on the other side. So like I need 6 of these anti-shorts, and this bag has 35 of them. So at the end of the video, I'll give away 29 anti-shorts worth 10 cents each. No. Anyway, now that we know what changes we have to make, let's do it. Sorry for the boring video, I thought this was important to make. One anti-short here, there we go, and here's this plastic thing. It's not that critical, but whatever. Not bad. It looks like a joke. For my type of wire, I have to use this type of connector I used everywhere else that goes on outside of the box, so I can't use this either. Now we connect our wires back to the breaker, make sure the breaker is off, and then plug it in. There we go. Now we turn it on. Okay, nothing blew up. Let's go test the heater. All right, the heater turns on. Now we turn the breaker off and go put anti-shorts at the end of every jacket. Another jacket here. Another one around here. One more thing you mentioned was that this outlet is not to the code because it's rated for 50 amp appliances I put on a 30 amp system. But like I mentioned, this is only for my own diabolical testing, and I just wanted all the power lines to be available. There is a clause in the code that specifically mentions that I won't have to follow code if my installation is for personal diabolical testing. I'm joking, follow code. Anyway, this outlet here is what I provision for future electric car charging. So I was thinking I can move this 50 amp outlet there where it belongs, and I bought a 30 amp outlet that I can put here, and then I'll meet the code. There you go. I hope you're happy. You know, it would have been much more efficient if you had told me all these details before I installed the whole thing. Go, and the other one right here. Nice. Now I have to put the whole thing back. And it's all done. Thanks for staying to the end and pressing the like button.